So in section 3, all this is, this root right here is an indicator of how many of each type you need to pull out. So it's like a fourth root. So 16 can break down to 4 times 4, which is 2 times 2 times 2 times 2. So if I'm doing the fourth root, then my answer would be there's one group of 4, so my answer is 2. Like, you know how square root, if we do 4, it says what times what number gives you that. So we know that answer is 2. So what we're doing here is that's 2 times 2. We have a group of 2s that pull out. If you have a square root, there is an understood 2 to be there. We don't write that 2, Nora. That 2 is just understood. Okay? We don't have one for a 1. It wouldn't make sense. So, like, if we did that, if that was 5, and we do the square root of 25, that's 5, so we just don't put a 1. If we have a 3, and I do 125, that would give me 5. Okay, so that's the kind of the idea there. Okay? All right, so in number 2, 16 breaks down again to 2 times 2 times 2 times 2, and then I have an x and an x and an x. Now you can write that out like that if you want to. This is now looking for pairs there, Ari, so I get that, right? So each one of those pairs comes out, so I'm going to get 4x in front, then I'm going to have the square root of x left underneath. Now, square roots, just so you know, Nora, we have an issue if we have the square root of 9. That could be like the square root of 3 times the square root of 3, or it could be the negative 3 times negative 3. So my answer could be 3, or it could be negative 3. Well, it has to be one or the other. It's not both. Okay? And the reason why is that we have, x is an unknown. So if I have like the square root of x squared, it looks like x. But this can't happen. We can't have a negative. So we have to ensure it's always positive. So we're going to throw absolute value symbols around it. Okay? So it only affects those indexes that are even. So like number 1, like number 2, and like number 4. Those all have even indexes. So therefore, those possibly need an absolute value. So if it's a variable, we're going to have to ensure it. So we have to put absolute value symbols around that x. That is the correct answer. Now, if I'm looking at number 3, that's an odd one, and we're allowed to have negatives. So in this case, this is 2 times 2 times 2, and x times x times x. Really, most people see that as negative 2 times negative 2 times negative 2. Okay? So we are going to pull out a negative 2. And we're going to pull out an x. So my answer is really negative 2x. It doesn't need absolute value symbols because we're allowed to have one, because we can multiply 3 negative numbers to get it together to have that happen. Now, to help them visually on this one yesterday, Nora, we went over like the square root of x. If I graph that one, it is a graph that looks like this. And as you notice, they're all positive. All those numbers are positive. So I can't get any negative ones. There is a hidden, like, parabola, but we don't use those because they're imaginary, all right? But the imaginary numbers are going to come out towards you, not underneath it. The cube root of x there, just so you can see this one, Nora, looks like this. So we have negative answers, and we have positive answers. So that's why we don't need this. This one we need absolute values. This one needs absolute values. This one doesn't. Okay? So just things to do. All right, now, this one right here says a fourth root, so I'm looking for groups of 4. And as you can tell, I have 4 x's, so therefore that is just x. But it's a fourth root, so it needs absolute values. Now, Reese is noticing all I'm doing here is taking this right here and dividing it into that right there. It goes one time. And so that can work. So if I had like the fourth root of x to the 16th, 4 would go into 16 4 times, right? So I would get an answer that would be x to the 4th. Do I need absolute values on x to the 4th? Autumn says no. Reese says yes. Dexter's him-hawing. I don't know if he says yes. Autumn's right. Why is she right? We do not need absolute value symbols on this one. What makes that true? Why no absolute value symbols? Because a negative times a negative is a positive, and a negative times a negative is a positive. There are 4 negatives in there. That's automatically. This is an automatic positive, so I don't need absolute value symbols around it. Does it make sense? So if it was an x to the 3rd power, then I would need absolute value symbols. So it's only when this index is even and the powers that come out are odd, you would need absolute value symbols. Okay? So, I don't know, even odd. Just remember even odd. When you're working on these, go, oh, even odd needs absolute value symbols. Even odd. Little chant, whatever makes it happen, happens. I'd rather you do that. All right, now, this gives you an x. Absolute value symbols there. Lakota says yes. What's my index here, Lakota? Is that an even number or an odd number? And it's an even odd needs. Even odd. That's not even, so we wouldn't need them. This graph right here, Lakota, would be like the cube root of x. The 5th root of x would all be the same. So they would look like that. Okay? Just stretched more if you have a 5th root. So they have positive negatives. So we do not need absolute value symbols. Okay? So again, this one would be a no abs. What about 7 and 8? Abs or no abs? These would be no abs. I mean, no absolute value. So these would not require it. This one, maybe. Okay, does it make sense? Because it's even. 52 breaks down to? What's that, 52? It's even. 26, what's after 26? 13. And then I go x, 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 y, 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 y. And then I put my square root symbol. And then this has an indicator of, or index of 2. So I'm going to circle all my pairs. Now, some of you guys may not do it this way, and that is fine. I will probably do it a lot like this. Because now I know these are all going to go out front. There's 3 of my x's and there are 2 y's. Then I draw my square root symbol, and what's not circled stays underneath. Okay? Now some of you guys may go, all right, oh, that's 4 times 13. So I know the square root of 4 is 2. The 13 stays underneath. Then I take the 2 and I divide it into the x, which gives me 3 of them, and 2 goes into 5. 2 times, leaving me 1 left over. There are different ways to do that. That's fine. But I am going to write it out, the prime factorization, most of the time, because a lot of kids, if this is the way to do it, I mean, really kind of bring it all the way down to the bottom of that, and you understand how to do it the other way, great. Do it the other way. I don't have any problems with that. Is that my final answer, Reese? Jason's saying he's shaking his head because he knows what's up. Absolute value symbols, right? We need absolute values around the x to the 3rd power. Only around x to the 3rd. You don't need anything else. 54 breaks down to what times what? Yeah, 6 times 9 or 2 times 27. However you want to look at it, I really don't care. Okay? That ends up being 2 times 3 times 3 times 3 when you get done with that number. And then I have y, 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 and y, y, y. And then I have x, 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 and a single x. And then I'll do the cube root. I don't make it a whole big line. You know how some people will stretch it out and make it very, very horizontal. You don't have to do that. And I even, when I'm writing them down, I actually group them in groups of 3s, so it makes it really, really easy for me to spot them. Okay? If I'm doing pairs, I do it in groups of pairs. If I'm doing quadruplets, I do quadruplets. Okay? So I'm left with 3, 1x, y to the third, cube root of 2x. Is that my final answer? Yeah, that's my final answer. Why do I not need absolute values? Because that's an odd index, and I don't need absolute values for a odd index. Okay? I know it's kind of tricky at the beginning. You got to practice these, okay? You'll get better at these. I think there's a homework tonight. It's really simple. It's not even hard at all. So 81 breaks down to? A bunch of 3s, right? And a bunch of y's. And a bunch of x's. And somebody goes, I don't want to write down 12 x's. You know how long did it take me to write down 12 x's? You know, I mean, really. You know, if it would guarantee you would get an answer on that, why not? Circle all those. Those are the ones get left outside. So 3x to the fourth y cube root of 3y squared. No absolute values needed. Oh, I got 9, 10, 11. Which one do you want? 11. All right. 48. What's that break down to? 3 times 6? 16. What was up with the big paws? I have no idea. I've had them my whole life. All right, now, 6 times 8, that is 2 times 3 times 2 times 2 times 2. Probably should have all those 2's together, but that's all right. X, 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 and X, and X, and X, and X, and X. I got a Y, and 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 a Y. One more. There's 17. Ooh, that's a lot of Y's. All right, so circle all the quadruplets. I can get that one. You can watch this. The 3's not circled. So a 2 goes out front, an x to the third goes out front, a y to the fourth is out front. Then you're going to write the little 4 and then the house, and you're going to put down the 3 and the y. Then you're going to look back and you go, do I need absolute value symbols? And you go, that's a 4th root, so yes, I do, because it's an even odd, and the one that's odd is x cubed. Made 100. See, it's not that bad. There's a lot worse things you took a test on today. So, hey, you did pretty good on that quiz the other day. So, yeah, pretty good. I graded it this morning and was like, woo! Congratulations.